Hello, Year 13, 33. Sorry for messing up your cover lesson today. I gave you the wrong questions. I've just got to do a couple of little things that I would have told you if I was teaching you in that lesson, and then you've got some exam questions to do. So my expectation is that with Aqua ions, you can construct this table, which is, I would call it the Couffé-Fayal table. Of course, you know how to do this. So I'm just going to do a very simple version of it, which hopefully you understand. It's very messy, but it doesn't really matter. So my expectation from you is that you could knock this table up super quick. We've got our acids down the side. We've got our bases across the top. Ammonia, excess ammonia, etc. So you know what I'm doing here. And then I'm going to scribble those three out. I'm going to scribble those three out. I'm going to say that that one is unusual, that one is unusual. We know that these are just metal carbonates and these ones fizz, and you need to be careful with balancing these equations. So, what I needed to tell you, if these were my revision notes, on the back of this sheet, I also want you to know this information. I want you to know that CuCl4 2 minus, which is this complex, right, which I'm just drawing on here, this complex, you need to know at A level that this is yellow. That is a yellow solution. Okay? So we know that's a yellow solution. So it's another one to add to your copper. And then also on the back of here, I would put my other ions test. This is important. So positive ions or negative ions. So we know Couffé-Fayal and all of those different things here. I also want you to remember the test for barium, the test for magnesium 2+, the test for ammonium. These are all ions that you know. So remember this one was add sulfates, white precipitate. This one was add hydroxides, white precipitate. This one, oh my goodness, I can't remember it. Warm hydroxide, litmus paper. It's up to you. Okay, you need to know these. And then your negative ions, you know your chlorides, your bromides, your iodides, acidified silver nitrate, Ag+, got this is scruffy in it. White, cream, yellow, dissolves in dilute ammonia, dissolves in conc ammonia, doesn't dissolve at all. So you've seen all of this sort of thing before. But my revision notes and your revision notes should have this on one side, aqua ions, and this on the other. I'll tell you why in about a minute. Okay, so that's what you've got. In other words, you're bundling this information together with your ions tests from last year, which, if you remember, you didn't know particularly well. I like to get everybody back to learning. So, aqua ions and group 2, group 7 ions tests. I've got another thing to put on here, of course, sulfate, which is barium chloride solution, Ba2 plus SO4 2 minus makes BaSO4 solid. What else is on here? Carbonates, react with an acid, you make carbon dioxide, CO2 plus H2O, then you're going to bubble the carbon dioxide through lime water. I think I've done them all. Right. Going to go back to this diagram. I've got one little bit more for your notes now. And it's about this chemical here. Very important. This chemical, as you know, is the white precipitate Al OH3 H2O3. You can put the OH and the H2O the other way around. I just decided to do it that way now. And we know this is a white precipitate. Okay. What we know from this, I'm just going to zoom in. What we know is that this chemical can be reacted with more OH minus, and that will turn it into this box. You also know that if I add H pluses, I can turn these OHs back into H2Os. So what we have here is a chemical that can react with bases and acids. Now that's a special type of chemical. A chemical that can react with bases and of acids is known as amphoteric. So if I was to put that into a sentence, aluminium, OH3, H2O3 is amphoteric. That is on your specification. And it is amphoteric because it can react with H pluses, which will turn it into Al H2O 6 times 3 plus again, or it can react with more OH minuses that will turn it into Al OH6 3 minus. Alright? 3 of these, 3 of these. Now you might be thinking, great, well, what's so special about that? I'm just going to point out some of these other chemicals. This chemical here, which is Cu OH2 H2O4, or again, you can put them the other way around, that cannot react with extra OH because this is blocked out, but it can react with H+. In other words, this chemical, this hydroxide, is a base because it reacts with acid. This one is also a base because it only reacts with acid. It can't go that way. Iron 3 plus is a base because it can't react. Sorry, it's a base that only reacts with acid. This is a base because it only reacts with acid that way. It can't react with any more base. Only aluminium is amphoteric. I think that's the only bit I needed to tell you. Last little summary because I can't leave it like that. So we've done the amphoteric bit. This bit, aluminium hydroxide is amphoteric. What else we knew? CuCl4 2 minus is a yellow solution. That is something you have to learn. And then the last bit of advice was bundle them all together on here. Now then, you would think, because it sounded like I was about to wrap up then, but I was about to wrap up, but there's one other thing I want to say. This question, and it's on your question path. This is why I'm getting you to do it. Because it was a question from 2 years ago. You're given this set of tests. You were given 2 aqueous solutions that both contain iron salts. So already I'm thinking this is probably a question about Fe2 plus and Fe3 plus. And they're salts, which means it could be iron nitrate, iron chloride, iron carbonate, whatever. A student does a series of tests on the solution. So what they're going to do first is they're going to add ammonia, and a red-brown precipitate was formed, and a green precipitate. So straight away, I know it's iron 3 plus, and this is iron 2 plus. They're then going to add carbonate, and you get a red-brown precipitate, and it fizzes. So that backs up the fact that it's iron 3 plus. I know we just call it a brown precipitate, but you need to adapt, be a bit flexible with that. And you get this green precipitate here, which forms. So that is green precipitate, FeCO3. This is FeH2O4 OH2. This is FeH2O3 OH3. This is FeH2O3 OH3. So the same precipitate there. Add dilute nitric acid. They don't fizz, so they are not carbonates. That's what that means. Add barium chloride, you get a white precipitate. The white precipitate must be barium sulfate, so this must have sulfate ions in. This forms a white precipitate with silver nitrate, so this must be chloride ions. So I've gone through all of those, and I now know that this chemical must have had iron 3 plus and chloride, therefore it is FeCl3. This is iron 2 plus and sulfate, therefore it's FeSO4. That only gets you a couple of marks. What you've got to do is identify all the precipitates, explain why effervescence is seen for 3 plus. You get fizzing here, but not here. That's about acidity and charge density. Give ionic equations for all reactions. You've got to practice this question. Alright? So you'll notice it's got Coupe-Fayal and it's also got ions test. Right, that was 9 minutes. Much of it was me waffling because I've had a very, very busy day with interviews. Thank you for putting up with my lack of preparation and planning. Much appreciated. Yeah, it doesn't go unnoticed. So thank you. All right, have a good weekend, everybody. Goodbye.